Okay, so we're already at number 4, and number 4 is about the antiderivative. So, okay. Very easy to answer this question too quickly. Maybe you should pause the video and answer the question and then either come back and listen to my BS or just go on to the next thing. So what does the antiderivative mean? It means we want to find this function f of x, which we think exists. And what capital F does that's special is its derivative is f. So we want capital F so that capital F of x prime, the derivative of it, is just f. So 1.7 x 2.4. Okay. So I didn't put in what you fancy literary types will want to refer to as an article here, like a or the. So is it the antiderivative or is it a antiderivative? It turns out that there are many antiderivatives, but they're all really similar to each other. They're all translations to each other, and you don't have to understand that right now because you're going to get it a lot more later. And I think you'll have a good idea of what I mean by that by the end of the problem, hopefully. All right, so let me just remind you of the power rule. I can write down the power rule, and I can say all kinds of things, but okay, so the power rule, it says that if you have a function like, it says if y is equal to, say, a times x to the r, where a and r are any real numbers, so any reals, then it's the case that the derivative of y with respect to x, so it could be doing this using the prime notation too, whatever, or using the Leibniz notation, is equal to the r comes down, the a hangs out, x is still here, and the exponent is reduced by 1. Okay. So we want to do that backwards. Could you call it maybe the anti-power rule? Anti-power, I can't write that without putting exclamation points after it. Rule. Okay, and what does the anti-power rule say? It says that if, let's write it like this, if f of x is equal to a times x to the r, then, so for now let's just let capital F stand for some antiderivative. So capital F of x is equal to, what should it be? Okay, so just like when you take the derivative, the exponent comes down, so when you take the antiderivative, the exponent must go up. And you leave a alone when you take the derivative, so you probably leave a alone when you take the antiderivative. So let's write a, and let's take a guess here, and do r plus 1. Okay, but you can see this isn't quite right, because if I take capital F prime, the r plus 1 will come down, the exponent will change to r, but then I've got that dumb r plus 1 in front. So to stop that from happening, I need to divide by r plus 1. Okay, all right. And there's another little subtlety here, which is that if r is minus 1, then you've got something silly happening here. If r is minus 1, then you're saying that the antiderivative is something divided by 0, because minus 1 plus 1 is 0. And so you'll find out what happens when r is equal to minus 1 later. There's an explanation of that, but for now let's just assume that r is not minus 1. Okay. Alright. So here now I have a formula. So once you have a formula, the problem is always done. All right. Okay, so what is it? Let me remind myself. So it's going to be a times x to the r plus 1 divided by r plus 1. Okay. So a here is 1.7. So it's 1.7 times x to the 3.4 divided by 3.4. Okay, and this is times, okay. And so that's it. And let's check it. I mean, maybe it's the first or second time you've ever done this before. So prove it. I say we're done, but we're going to prove it just so we can sleep tonight. So what happens if we actually compute f prime? Then the 3.4 comes down and I get 3.4 times 1.7 times x to the 2.4, and x is still over 3.4, and you're saying, what is that? You're changing the rules. But I'm not changing the rules because I'm thinking of 1.7 times this thing in the denominator is really like 1.7 over 3.4, and so this is like my constant a. So I just leave it alone. See how these two things make up my constant? So I really can just leave the 3.4 there. And then they cancel. So this 3.4 cancels with its enemy, and you get left with 1.7 times x to the 2.4. And so it's true that the derivative of capital F is the original function. And so we're done. Okay, we're done. So before I confuse you even more, turn off this video immediately. But if you're still here, you can say something about when I was being kind of all smart and mysterious talking about there being many antiderivatives. So if there are many antiderivatives, what was I talking about? Because I just gave one. We used the formula and we got one. What was it? The one that we got is capital F equals 1.7 times x to the 3.4 over 3.4. So now you are entitled to say, okay, smart guy, where are the other ones? So the other ones are all of the form this plus some number. Like what if I do plus 10? Okay, so you can see that if I do plus 10 here, the 10 ends up not making any difference because when you take the derivative, the constant goes to 0. And there's nothing special about 10. You could also put 36 here. And so what it is that all the antiderivatives are the same except for this plus something. And geometrically what that means is that all the antiderivatives are just vertical translations of one another. And that makes sense if you think about it, because where the y-intercept of the curve has nothing to do with the tangent line, right? So if I think of the slope of the tangent line here is the same as the slope of the tangent line here is the same as the slope of the tangent line there. So the derivative kind of forgets the y-intercept, and the algebra, the way it comes out is plus something is also an antiderivative. And that's the end of the problem.